All right, hey guys, here are the answers to homework number 4. Check them out. All right, let me go through how to do these. Most of these are one of two types. You are trying to determine if a graph represents a linear situation or not, and you're trying to decide if a table of ordered pairs would be linear or not. So, graphs are very easy, right? A graph is linear if it makes a straight line. It is not linear if it doesn't. Obviously, this first one makes a straight line, so it is linear. The second one makes a U-shape. That's called a parabola. And, of course, that is nonlinear because it does not make a straight line. Third one makes a U-shape. Again, because it's not a straight line, it would be nonlinear. And the fourth one makes a straight line, so it is linear. Problem 2. Problem 2, I have to look at the table and see if it's linear or not. It's linear if the change in y over the change in x, right? That's called the rate of change, if that is constant. So let's check and see if it's constant. The x's are going by 1 every time, right? Increase by 1, increase by 1. The change in x is always 1. What about the change in y? The change in y is 2, 2, 2. The change in y is always 2. So the rate of change is constant. It's 2 over 1. And because it's constant, we can say that that is linear. Part B asks us to write a rule, right? A rule is an equation. And to write the equation, right, we have to figure out two things. We have to figure out first the slope or the rate of change. And we already figured that out, it's 2. So already I know my equation is y equals 2x plus something. The other thing I need to figure out to write an equation, not only do I have to figure out the slope, I have to figure out the y-intercept. And remember, the y-intercept is the y value when x is 0. So I have that point right here. 4 is the y value when x is 0. That makes 4 the y-intercept, and my equation would be y equals 2x plus 4. All right, again, linear or nonlinear. So to check linear or nonlinear, I need to see, is the change in y over the change in x constant? Let's see. It looks like I'm going plus 2, 2, 2, 2. Here I'm going 6, 6, 6, 6. The rate of change is constant. It is 6 over 2 for all of them. Therefore, this table is linear. Again, linear or nonlinear. So again, I'm going to check, is the change in y over the change in x? Is it constant? So let's see. The x's are easy. They go up. The change is 1, the change is 1, the change is 1, the change is 1. The y's go plus 3, then they go plus 5. Okay, already, the first one is 3 over 1. The second one is 5 over 1. Those aren't the same. This one is nonlinear. Number 5. The table shows the population of growth of mice. Does the table represent linear or nonlinear? Well, up 1, up 1, up 1, up 1. So the change in x is always 1. The change in y is 400 when you go from 200 to 600. Then it's 1,200. And obviously I can already tell, here it was 400 over 1. Here it's 1,200 over 1. Those are not the same, so this one is non-linear. We go to number 6. Which functions are okay, so these are graphs again. Obviously, this does not make a straight line. It makes a V shape, so it is nonlinear. This one makes a straight line, so it is linear. This one makes a straight line, so it is linear. Number 7. A student was asked to decide which table or tables represent a linear function. All right, so for all the tables, I'm going to do the change in y over the change in x and see if it's constant. This one is 4, 4, 4, 4, negative 8, negative 8, negative 8, negative 8. This one is negative 8 over 4, constant. So this one is linear. The second one goes up 2, goes up 2, goes up 2, and goes up 2, goes up 7, goes up 9, and 7 over 2, not the same as 9 over 2. So in this one, the change in y over the change in x is not constant. This one is not linear. And that brings me to the last one, where the x values go minus 4, minus 4, minus 4. Okay, the change in x is always minus 4. The change in y is minus 12, minus 12, minus 12, minus 12. That one has a rate of change of negative 12 over negative 4. And it is constant. It's always negative 12 over negative 4. That one is linear. So my answer is first and third table. These two are the ones that are linear. Next up, I got the population of mice. Double every 3 months, the table shows. Okay, so it doubles every 3 months. So let's see, is it linear or nonlinear? Well, to check linear or nonlinear, I'm going to check the rate of change. 3, 3, 3. So the change in x equals 3. The change in y is 22, 44. Well, already I can tell it's not linear, right? Because 22 over 3 is not the same as 44 over 3. So this one is non-linear. How many ants will there be in the ant farm after 1 year? Well, in this case, I might want to continue the pattern in the table. Can I continue the pattern to figure out how many mice there'll be in 1 year or 12 months? And the pattern is that they double every 3 months. See, 22 to 44, they doubled. And 44 to 88, they doubled. And they doubled, so if I double 176, I get 352. After 1 year, there will be 352 mice. And that brings me to the last one. Again, I have graphs. I hope these graphs are easy for you. This one does not make a straight line, right? Linear or nonlinear? Ooh, if it is linear, I got to write the rule. Okay, well, this one is nonlinear. And this one is nonlinear. But the middle one is linear. So if I'm going to write the rule for this, I need to figure out the slope and the y-intercept. All right, well, the y-intercept is right there. It's 0. The slope is a little tough to tell because the boxes are so small. It looks like that's a good point right there. And I could get the slope by doing the rise over the run, which looks like 5 over 5, or just 1. So I know the slope, I know the y-intercept, I can write the equation y equals 1x plus 0. Or a better way to write that would just be y equals x. And last up, I need to look at each table and decide linear or nonlinear. And then if it's linear, write the equation. So, to decide, let's see, decide which of these tables represents linear or nonlinear. All right, to do that, I'm going to check the change in y over the change in x and see if it's constant. All right? So here I'm going up 3 at a time. The change in x is 3. The change in y is 3, 5, 7. Okay, it looks like it's not linear because the change in y over the change in x is not the same every time. So this one is nonlinear, and I do not have to write the equation. We go to the second one. The change in x is 2, and 2, and 2. All right, if it's going to be linear, the change in y needs to be the same. The change in y is minus 10, minus 10, minus 10, minus 10. So the change in y over the change in x is constant. Therefore, this one is linear. The change in y over the change in x equals negative 10 over 2, which is negative 5. That's important because for this one, if it is linear, I have to write the rule, which is the equation. And to write the equation, the first thing I need is the slope. And the slope is the rate of change. So this equation is going to be y equals negative 5x plus something. I also need to figure out the y-intercept. Remember the easy way to get the y-intercept? Figure out what x is, or what y is, when x is 0. So if you look at the table, and you look at the x values, see how they go down by 2 as you go to the left? 10, 8, 6, 4, 2. Wouldn't the next input be 0? Now follow the pattern for the y's. The y's are actually going up by 10 as you go to the left. So if I continue the pattern to the left, the next one would be 29. The y value is 29 when the x value is 0. So the y-intercept is 29. And I've got my equation. Last up, the last table, let's see what it looks like. The change in x is minus 3, minus 3. It looks like it's always minus 3. The change in y, oh my goodness. Well, I'm not sure what that is. I guess it's about 191 or so down. But here it's only minus 27. And here it's minus 27. And then it gets huge again. So it looks like, oh, it's actually plus 27 there, isn't it? And then it's plus 191, I think. Either way, definitely not linear. It's not constant. So this one is nonlinear. And I do not have to write the equation for the nonlinear. Hope that helps. Good luck on the review.